Today's lesson is exercise 8E, arrays. Now I know this chapter is called two-step experiments using tables in the textbook and planning document, but I don't want you to get confused with two-way tables. So we'll use the heading array because that's also another correct terminology. An array is used to show sample space. It displays the outcomes of a two-step experiment. This is what an array looks like. This is for the first step of the experiment. Here we list the possible selections. And then here is the second step of the experiment. This is two-step experiments. And here's where we list the possible selections. And in the middle of the array here, in these boxes, this is where we write the outcomes. So this is like a basic example. Two coins are tossed, show the sample space in an array. So the first coin that's tossed could either be a head or a tail, and the second coin that's tossed could either be a head or a tail. So they're our selections. Then we list the outcomes, so we could get a head and then a head, we could get a tail and then a head, we could get a head and then a tail, or a tail and a tail. What's the probability of getting a head and then a tail? A head and then a tail, that's only this option here, 1 in 4. The probability of getting one head, so this is one head and this is one head, so that's 2 out of 4. There are two different types of experiments. The first type is with replacement, so outcomes can be repeated. For example, if we think of the probability of picking a blue marble, it is 3 out of 5. And so in the first step of the experiment, we pick out a marble. And then for the second step of the experiment, it's with replacement. So we put that back in. So now for the second step of the experiment, there's still the 5 marbles in there, and the probability of getting a blue is still 3 out of 5. The second type of experiment is without replacement. So the outcome cannot be repeated. So for example, same thing, the probability of getting a blue marble is 3 out of 5. So in the first step of the experiment, we take out 1 and it's a blue marble. So then it is not replaced. So it's without replacement, so we don't put it back in this time. So now there's only 4 marbles in there. So the probability now of getting a blue is 2 out of 4. So I'll just show you the difference in an array. So 2 selections are made from the letters A, B and C. So the first experiment has replacement. So we could get an A and an A, we could get a B and an A, C and an A, B, 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 C, B, A, C, B, C and C, C. But if we conducted the experiment without replacement, so on the first selection, we get an A, but it's without replacement. So that means the A doesn't get put back in there. So then I can't actually get another A. So this would just be crossed out. We can't have 2 of the same things. We could have a B and an A C and an A. We could have an A and a B. We can't have a B and a B, because if a B is selected on the first step, then it's not put back in there, so we can't select it on the second step. We could get a C and a B, A, C, B, C. And if we select a C on the first step, it's not replaced, so we can't select it on the second step. We'll just do one more example from the textbook. This one's similar to the one that's on the test. A first six-sided die is rolled twice. List the sample space using a table, so an array. So we could have a 1 and a 1, 2 and a 1, 3 and a 1, 4, 1, 5, 1, 6, 1, 1, 2, 2, 2. Alright, you guys get the hang of it, so I've just already filled it in. So this is what the array would look like. These are the sort of questions you can expect on the test. State the total number of outcomes. So there's 36 outcomes altogether. Find the probability of obtaining the outcome 1 and then a 5. 1 and then a 5, that is here. So 1 out of 36. Okay, next one. Find the probability of a double. So a double means the numbers are the same. So these are our doubles. So double, there's 1, 2, 3, 4, 5, 6. 6 out of 36. Probability sum of at least 10. So that means 10 or more. So 10 or more, we just add up the sum. So that's, I'll just write here, add. So they add up to at least 10 or more. So 10 or more, that is this, this, this. These are the ones that are at least 10. We've got a 10, an 11, 10, 10, 11, 12. Right, so there's 1, 2, 3, 4, 5, 6. So 6 out of 36. And the probability sum not equal to 7. So the amount that are equal to 7, we've either got 1, 2, 3, 4, 5, 6. So there are 6 that are equal to 7. So not equal to 7, that's 30 out of 36. Okay, then the last question. Find the probability of a sum of 12 given that the sum is at least 10. So given that, that's our conditional probability from the lesson before. So the probability that at least 10 has already happened. So that's this section here. And the probability that it's a sum of 12, that's this one here. So 1 out of 6. Okay, make sure you copy all those board notes, and then there's an array worksheet to do and submit to my Panola.